Most DJI drone problems don't begin in the air. They begin much earlier before the props ever spin, at the moment when the pilot decides that everything is already under control. Batteries are charged, GPS is locked, the weather looks fine, and the drone feels stable. At that point, most people mentally switch off. They stop actively flying and start supervising. And that shift, like from active control to passive trust, is where most long-term problems quietly originate. DJI drones are extremely good at creating a feeling of safety. That is one of their biggest strengths, and also one of the reasons people make the same mistakes over and over again. When a drone feels stable, smooth, and predictable, it encourages the belief that nothing unexpected is likely to happen. But stability is not the same thing as understanding. A drone can appear perfectly under control while still operating very close to its limits, and the pilot may have no awareness of that until it's too late to react calmly. One of the most common mistakes people make is assuming that automation equals intelligence. DJI's automation systems are excellent, but they are not thinking systems. They don't understand your intention, your surroundings in a human way, or what you are trying to achieve creatively. They simply respond to inputs and sensor data within predefined boundaries. When everything stays inside those boundaries, the flight feels effortless. When something pushes beyond them, the drone does not warn you early, per se, it reacts late. This creates a dangerous illusion. Pilots begin to believe that if something were truly risky, the drone would stop them. In reality, DJI drones are designed to assist, not to prevent all bad decisions. They assume a baseline level of pilot awareness. When that awareness drops because everything feels easy, the system no longer has a buffer to work with. Another subtle mistake happens when people confuse confidence with familiarity. After a few successful flights, the controls feel natural, takeoff feels routine, and the fear disappears. This is a good thing, but it often leads to complacency. Familiarity reduces caution faster than experience increases judgment. Like, many pilots reach a stage where they feel confident, but they haven't yet encountered enough varied conditions to understand why things go wrong. This is why so many incidents happen after the beginner phase. Not in the first flight, but in the 10th, 20th, or 50th flight. The pilot knows how to fly, but hasn't yet learned how the drone behaves when conditions are slightly different than expected, wind from a new direction, lighting that confuses sensors, or terrain that alters signal behavior. None of these feel dramatic at takeoff, but all of them can compound quietly. Another mistake is assuming that a calm takeoff guarantees a calm flight. Many pilots judge conditions based on the first 30 seconds in the air. If the drone feels stable and responsive, they conclude that the environment is safe. But conditions change with altitude, distance, and direction. Wind that is barely noticeable near the ground can be significantly stronger just a few meters higher. The drone compensates automatically, so the pilot feels nothing until the compensation reaches its limit. DJI drones are very good at hiding effort. Motors work harder, power draw increases, and control margins shrink, all without obvious feedback to the pilot. This creates a delayed awareness problem. By the time the pilot notices something is wrong, the drone has already been operating under stress for a while. At that point, decisions become reactive instead of deliberate. There is also a widespread misunderstanding about what safe flying actually means. Many people interpret safety as following rules, waiting for GPS lock, and avoiding obvious obstacles. Those things matter, but they are not the whole picture. True safety comes from understanding how small factors interact over time. Distance, wind, battery load, and return path all influence each other. Ignoring those relationships doesn't cause immediate failure. It causes gradual risk accumulation. Another foundational mistake is treating DJI drones as if they behave consistently in all environments. A drone that feels predictable in open land may behave very differently near buildings, trees, cliffs, or water. Signal reflection, airflow disruption, and visual interference can all change how the drone responds. Because DJI systems smooth out these effects, pilots often don't realize how environment-dependent flight behavior actually is. What ties all of these mistakes together is not carelessness, but misplaced trust. Trust in automation, trust in past experience, and trust in the feeling that everything seems fine. DJI drones are designed to make flying accessible, but accessibility can quietly reduce attentiveness. When attentiveness drops, the margin for error shrinks. Not suddenly, but gradually. The key takeaway from this first part is simple but uncomfortable. Most DJI drone problems don't come from dramatic mistakes. They come from small assumptions stacking up over time. Each assumption feels reasonable on its own. Together, they create situations where the pilot is always one step behind the drone instead of one step ahead. Understanding this mindset shift is essential because all of the more visible mistakes, battery issues, water flights, wind problems, and lost footage, grow out of these early mental shortcuts. If you don't fix the thinking, the technical advice doesn't stick. Once the mindset mistakes are in place, the technical problems start appearing, not suddenly but predictably. These are the moments pilots usually describe as unexpected, even though in hindsight the warning signs were always there. DJI drones rarely fail without explanation. What fails first is the pilot's understanding of what the drone has been compensating for quietly. One of the most misunderstood aspects of DJI flying is battery behavior. Most pilots treat battery percentage as if it were a countdown timer. 30% feels like plenty. 20% still feels usable. But battery percentage is not a measure of time remaining. It is a rough estimate of energy available under ideal conditions. The moment conditions change, that estimate becomes unreliable. What many pilots don't realize is that power demand increases dramatically when flying against wind, climbing, or stabilizing aggressively. Voltage drops under load, and when that drop happens, the drone doesn't slowly ease into trouble. It recalculates risk instantly. That's why return to home warnings can feel abrupt. The drone isn't panicking, it's recognizing that the margin for a safe return has collapsed faster than expected. This is especially common on flights where the drone travels outward. With a tailwind, everything feels smooth, efficient, and effortless. Distance increases quickly and battery usage seems low. The mistake happens when pilots assume the return will feel the same. When the drone turns around and meets resistance, power draw spikes, voltage drops, and suddenly the drone behaves very differently. At that point, decisions are no longer strategic, they're urgent. Flying over water amplifies these issues in ways that are not immediately obvious. Water appears flat, open, and forgiving, but from a drone's perspective, it removes almost every safety net. Visual sensors can struggle with reflections, downward positioning systems can lose reliable reference points. Wind over water is often stronger, more directional, and less predictable than over land. And if the drone needs to descend unexpectedly, there is no margin for error. What makes water flights particularly deceptive is how normal they feel at first. Takeoff is smooth, hover is stable, hover. Everything looks calm. Because there are no obstacles, pilots often relax more than they should. But if the drone encounters a sudden change in wind or needs to compensate aggressively, there is nowhere to recover. Over land, a forced descent may be inconvenient. Over water, it ends the flight permanently. Wind is another area where DJI drones quietly hide danger. Most pilots think of wind as something obvious, trying strong gusts, visible movement, or audible noise. In reality, wind often becomes dangerous through inconsistency, not strength. Directional shifts, shear layers, and thermal lift can exist even on visually calm days. DJI drones compensate extremely well, which means the pilot feels almost nothing until the drone reaches its performance limit. This creates a delayed feedback problem, motors work harder, power consumption increases, stability algorithms compensate more aggressively. All of this happens invisibly. By the time the pilot notices drift, sluggish response, or warning messages, the drone has already been operating under stress for some time. At that point, safe options are fewer and reactions are rushed. Another mistake that frustrates creators more than crashes is discovering unusable footage after the flight is over. Focus errors, incorrect exposure, stabilization artifacts, or unintended settings often go unnoticed until the footage is viewed on a larger screen. By then, the opportunity is gone. The location has changed, the light is different, the moment cannot be recreated. This mistake happens because DJI drones make it very easy to assume everything is being handled correctly. Autofocus, auto exposure, and stabilization work well most of the time, which encourages trust, but small mismatches between scene conditions and settings can still occur. Taking a minute to review critical shots immediately after landing is not wasted time, it's feedback. It closes the loop between flying and learning. There is also a tendency to treat DJI warnings as interruptions rather than information. Low battery alerts, when warnings, and signal notifications are often dismissed because the drone appears stable, but these warnings are not telling you something has already gone wrong. They are telling you that the margin is shrinking. Ignoring them doesn't cause immediate failure. It removes options later. Over time, these habits stack, flights become longer, distances increase, conditions vary, the pilot grows more comfortable, but not necessarily more attentive. And when something finally goes wrong, it feels sudden and unfair. In reality, it was the result of small, reasonable assumptions made repeatedly. The most important thing to understand is that DJI drones are not fragile. They are extremely capable machines, but they are designed around the idea that the pilot remains mentally engaged, even when flying feels easy. Automation handles stability, not judgment. Assistance smooths behavior, not consequences. The difference between confident pilots and frustrated ones is not skill level. It's awareness. Confident pilots are rarely surprised by their drones because they understand what the drone has been doing quietly all along. They notice patterns, they anticipate changes, they respect the gap between what feels safe and what actually is. If there is one idea to take away from this entire video, it's this. DJI drones don't punish mistakes immediately, they allow them to accumulate. And that generosity is what makes understanding these mistakes so important. Once you stop assuming the drone has everything covered, flying becomes calmer, safer, and far more predictable. None of this is meant to discourage flying. It's meant to remove surprises. When you understand what your drone is compensating for, wind, power, environment, and automation limits, you stop reacting and start deciding. And that is where DJI drones truly shine. If any of these mistakes felt familiar, that's normal. Every experienced pilot has made them in one form or another. The difference is learning to recognize them early. And if you want to go deeper into any one of these situations or see how they apply to specific DJI models, let me know. That's where the most useful follow-up videos come from.